red flags, I'd like to tell you a story, well really a cautionary tale. This peer-reviewed medical journal a few years ago published a paper stating a cosmetic anti-aging product improves photo-aged skin, a double-blind randomized control trial. Now this type of experiment is really the best type of experiment for giving us evidence about the effectiveness of some drug or treatment. This paper reported a statistically significant improvement in facial wrinkles as compared to baseline, p.01. So pretty clear evidence something was going on there, whereas the placebo cream, the control cream, led to no significant improvement. And this paper led to the populist press reporting, claiming significant clinical improvement in facial wrinkles, which resulted in large numbers of people storming Boots the chemist, the drugstores up and down Britain, battering down the doors to buy number 7 Protect and Perfect Intense Beauty Serum to apply to their wrinkled faces. Well, hold this thought, particularly these two pretty clear p-values there. Now consider this picture. Two means with 95% confidence intervals. And what's the overall impression that these two intervals give you? If I now put some labels on, perhaps you can see where this is going, and consider where these confidence intervals fall in relation to a null hypothesis value of 0, and you'll see that the p-values are exactly as in that paper, 0.01 here, pretty clear evidence of something going on, and 0.1 here, no significant effect. But the trouble is that concluding no effect for this placebo condition is basically accepting the null hypothesis. And a confidence interval this long is certainly not positive evidence that an effect is 0. Well, this article was criticised and the authors had to revise it, and they finished up concluding a non-significant trend. In other words, no message at all, no clear result at all. P-values and confidence intervals are certainly closely linked, but the presentation format that we use, whether p-values or a picture with confidence intervals, can matter a lot in the conclusion we take from a study. And the trouble is that NHST promotes dichotomous thinking. We look at each condition and say there is an effect, there is no effect. And further, that if this has an effect and that doesn't, there must be a difference between the two. Quite unjustified. So NHST offers seductive but illusory certainty. And on top of that, the word significant seems to shout at us something important or big, something that matters is going on. By contrast, confidence intervals are much more informative. They tell us how much uncertainty there is and can prompt better interpretation. So the two are closely linked, but there certainly are important differences. The 4 red flags. First is beware dichotomous thinking. Prefer estimation thinking, so we'd like to know how large or to what extent this cream makes a difference. Beware the S word significant, which does not necessarily imply important or large. And beware accepting the null hypothesis. The p-value of 0.11 is certainly not evidence that there was no effect at all there. There was a long confidence interval. And fourth, beware the p-value. They certainly can mislead. P-value does give you an indicator of strength of evidence against a null hypothesis, but it can easily mislead. And there'll be a 5th red flag to come in Chapter 7. My conclusion is that the first overall impression that you probably got from this picture is accurate and a better guide than any number of p-values. Looking at this picture, we probably decided that, well, these two overlap so much that we've got two results here that are pretty consistent. Certainly no evidence that they differ in any important way or to any important extent. And so looking at these confidence intervals is much more informative than just focusing on two p-values. My conclusion is that estimation is informative, likely to lead to justifiable conclusions. P-values, by contrast, can very easily mislead you. Avoid dichotomous thinking, avoid p-values, and focus on effect sizes and confidence intervals.